0 viewers. All right, looks like we're live, Dean.
Okay, so we're going to go through how lava is actually organized. We're going to go through the diagram of how Django organizes its calls and requests, follow that down through the code. We're also going to have a look at how the dispatcher works, and particularly how to develop new code for that, and then some other topics at the end about how to extend the existing software. So if we switch over to my desktop view, this is the page that most people will land on and most people spend most of their time on in Lava. So we're just going to drill down and see how this is actually built. So from the URL, it's just down there as localhost scheduler. So if we come into the actual code, this would be in Lava server. And as we follow the Django model, a request comes in from the browser, it goes off to Apache, Apache sends it through uWSGI, and the first place it lands in any code you'll actually recognize and be able to modify is urls.py, which is this file. It's a whole bunch of regular expressions. The way to work out which one you're actually landing in is according to the menus at the top here. So dashboard, you'll end up in dashboard app. Scheduler, you'll end up in Lava scheduler app. Results is new. That's going to be stuff we can be looking at on from there. So urls.py. We're looking at localhost/scheduler. That's just so happens to be the top level regular expression under Lava scheduler app views. So that's the top level structure of all the URLs at this stage. And that tells us that if there's no other matches at all at Lava scheduler app, it just goes through to a function called index in Lava scheduler. We can follow that through following the standard Django model. You go from URLs to views. Now, if I start up at the top of this file, the quickest way to find where you are on this is to take the name here and say, right, I'm looking for a function called index. There we go. Now, I'm using PyCharm, and I'll come back to why PyCharm is really useful for that later on. But one of the nice little features of PyCharm is a little link here which takes me straight to the template. But you'll find the same information a bit further down here. So when you actually return from the view, part of the rendering will be the template file that actually comes down from there. The template is built from information that comes out of the queries that are done inside the views, and the views then call down to things that are defined in models, which is the actual objects in the database. So this one, a device type. And a bit further down, we'll have devices, and then a bit further down, test jobs. So this is, as far as models is concerned, it's a typical Django app. We've added extensions for restricting objects to particular users. So you can see here, test job isn't a standard model, it's a restricted resource, but that's just an extension on there. You can follow that through into the Django user privileges stuff, and that's easy enough to follow down from there. But these are standard Django model fields. The other thing you'll see here is that it's the original page is principally a set of tables. So we have tables.py, which looks at how to build a table. So this is using the Django tables extension package. And we have a base table, which is Lava table. And the nice thing, again, there with PyCharm, from the definition, hitting Control B takes you straight to the function in the relevant file for that actual base. So this is the base class that's based straight on tables table, and implements stuff like the search support that is in the tables. So the job table, that's where our restricted resource thing comes in. We have a special column that provides either a link or just the number if if you don't have privilege to see the job. You've got the no rendering of device. So those then form queries back down into models that goes off to the database and says, oh, what's the target group? What's the description? Blah, blah, and populates it back into this information that's then sent along with all the rest as part of the return to the template. So now you've had the request in from URLs, you've loaded all this information via views going off to the models and tables and everything else. You're now sending the result back through Django, just returning from this function, telling Django to combine this template file with all this data. And if we look at the template, like most templates, we extend an existing template, and then the next thing we do is load the table support, and then it's a mix of Django or Ginger 2 templating structures with blocks and conditionals and messages, and then you have a standard HTML, CSS structures for how you want the page to actually show. So if you're looking at this page here, these numbers come in. So online devices 8 out of 10. That comes in from the view there, num online, and then if you look for num online, that's where you find where it's actually rendered to the front end. That, as far as it goes, is the basis of how the Django side of Lava Server actually works, but there's a lot more to Lava Server than just that, and this is why we do all our development on a Debian-based distro with packaging support. Is because we've got a lot of daemons running in the background that actually support the processing of this. So you find that you can make changes in here, but the changes don't necessarily become effective until you start doing stuff with the putting the stuff into the right packaged paths and restarting daemons when necessary. So there are helpers, and there's documentation on how you actually build all of these options. Now, one of the main things with, here we go, we can do scheduler app. Again, I'm using PyCharm because it's got this nice little integration for the unit tests. So this is how we would actually run unit tests whilst developing. You can see just at the bottom, it's creating a temporary database. And this is where, when you're doing code development in server, this is where you spend a fair bit of time waiting for the database migrations to go through, because they are, and they get longer each time you actually do any work with these. But we'll just get through and run the scheduler app tests. Whilst those are setting up, those are also run here on a regular basis, at least daily, on staging. Okay, I haven't run that particular configuration for a while, so maybe that one didn't like it. Let's try that one. That's probably just a PyCharm local thing with lots of change between branches all the time. So here's the dispatcher unit test. This did start out at less than 50 when we first started the major amount of work on the dispatchers. That's now jumped to 213. It's going to jump again. Lava Server is currently running 400 odd, 450. It's probably going to go up again from there. We also do other tools like pile-in support, so we try and get, we're not going to get to 100. I think it would add a huge number of just random comments to disable various bits to get to there. And we also monitor the speed at which these unit tests run. That spike was due to a problem on the actual dispatcher, because the KVM suddenly started to struggle because it was doing a lot of other work at the same time. These unit tests also support our review structure, again, from the documentation on how to contribute upstream. It goes through how to set up all the different things for Gerrit. So you can see in these that the actual review changes are there, and then automatically LavaBot comes along and notifies you and then runs tests on there. So this is the full set there. It tells you where it started. It tells you which one it's actually applying, and then it runs through all the tests. So you can see there it ran 84 at that stage, it ran 22 there, and it ran 65 there. Equally, we have that for Lava Dispatcher. So again, it's added that particular review, and then it's gone down through all the different dispatcher ones, and anything involving pipeline here is the new dispatcher, and we're up to 203 tests on the. So talking about how you actually do the tests, if you go back and jump out of Lava Server and into Lava Dispatcher. So all the new code lives here under Lava Dispatcher pipeline. And what we can do is we can look at how we actually add, say, a new class of code inside the dispatcher. So we are still maintaining the current dispatcher, but the emphasis for all new development, new classes is going to be into the pipeline dispatcher and the new structures along those lines. There's a lot of documentation again on the design of the new dispatcher. Let's start at the top level. If you want to see exactly where it starts, you come in here under commands, and then there we go. So when we're doing a pipeline run up, we validate the job first, and then we actually just go down into run. Validation is a nice little step that we do on the structure of the job before we even start to run it. So how do we get to that point? We come into here with the parser. So this is where the YAML for the job submission now gets turned into real objects. And we work through each one, and we work out which classes are actually going to be built together to prepare. So if you've got a boot action, you'll come down to a boot select, test, and deploy will do the same thing on each of those levels. Now these are class methods. They work through the accepts functions here. So it works through each one and says, can you accept this job, yes or no? Simple set of queries on the device dictionary and the parameter dictionary, and just saying static data, given this, can you support it? The parser works with the first one that actually says yes, and builds a set of actions from there. So I'll have to follow that through. So say that the boot we've specified is uboot. Then you can see when we finally construct this as an instance, so this class method runs first, then we construct it, and what we'll construct is a uboot action, which is down here. Uboot action then says, right, I need to build some jobs or some classes to support what I need to do. So it has an internal pipeline, so this top level action will be action level 1, and this one will be 1.1, 1.2, 1.3, and 1.4. Each of these can have sub pipelines, and you can build this as a tree as you go all the way down. Generally, you don't need to worry about how the pipeline is actually constructed in terms of adding new classes to this. What you'd be looking at is the strategies file in each of the directories, and you'd be adding a new block to here. that will be based on this class method and the top level boot, and then building up the classes that follow on from there. You can always reuse existing bits of other classes and reuse entire strategies according to what's actually needed for that particular class. If we look at header job here, there we go. So that's a simple job under the pipeline. So you use, that's the deployment. We're doing a boot and we're doing a simple test. So that will build up. Now, if you go over to the unit test support of Dispatcher, you'll also find that there are sample jobs. So we can look at this one, which is quite similar to what was actually running on there, just more spaced out. And the nice thing again, we got comments in the job submission, yay! And you can also see how this actually gets built. So you can see here, this is what the actual pipeline contains for that description. You can see all the different classes and their levels and their structure. This is a class view of the same description you get from the front end after a job submission, which will be displayed in due course. Right. Just looking at. So if you're building a new class at any of these top levels here under actions, you're also going to be starting off with a new YAML file. So you start with something like this, and then you'll have to build a unit test based on that. Now, most of the actual boilerplate for this is already available in all of the other unit tests in the directory, so you can just generally import everything you actually need. And you start off with parsing your new YAML file and just making sure that it contains what you think it does. Then you can test what the different, whether the pipeline has been constructed exactly as you require it to be. So these are very important for later on. So if someone else makes a change elsewhere and they change one of these accepts class methods, then the unit tests have got to make sure that all the other jobs still actually pick up the correct pipeline. So that's why, for example, with this, I would be running something like this unit test on a regular basis. PyCharm again makes this easy because just over here there's a toggle auto test. And what that does is it will run this unit test or a smaller selection of these every time I stop typing. Within about 5 seconds, or configurable, I think it's about 10 seconds generally, then it will run the unit tests on the code you've got so far and show you which ones are broken, because you're bound to break them at the start. Now, as well as the unit test reports, we have a system of functional tests as well. So unit tests can go so far, they can get you to the point where you know that the structure's correct, you know that your parameters and the commands that you've built are going to be sent to the device. You can check all of those are correct before they're sent. But sometimes you still, or for certain operations, you still need to test that those commands actually do what you think they do. So this is where the functional tests come in, and there's a whole section on this in the documentation as well. I can point out from these, but you can follow the job submission. At the moment we're using the old dispatcher. This is quite easy to, we will eventually push this into the new dispatcher as a QEMU rather than KVM. But what we're doing is just booting a standard image and then running a single Lava test shell inside that then submits more jobs based on the XML RPC. So this comes back to the services you can get here. So we ask the scheduler for things like all devices. We ask for all device types. And we go through and ask about can submit to types. So this is the kind of thing that checks whether the automated user is able to submit to these particular jobs, these particular devices. And what we end up with is if I look at that one, you end up with a very large, oops. So that has its own results on from there, but if we look at the actual jobs, then you find on the next page, there's some of them. When was the last functional test run? So you end up with a whole bunch of there we go. So you'll see it submitting. Let's filter this back down. Oh. I'll find the jobs for that later. But you end up with jobs being submitted for each of the devices, each of the device types that can be supported with the jobs that are defined there. Now, what else was I looking at? Now, I got this. There we go. So this also goes through how to actually set up devices on the pipeline. So this is an example of how to actually set up these pipeline devices. Yeah. So this is just an example of the documentation that we are adding to go through all these different levels. There's a lot of stuff available here to go through, in particular on all the levels of getting the jobs running. Right. So just to finish off this, I'm going to briefly look at how to control external hardware, the options that we've actually got within that. You can do this inside you can do it inside a test definition. So in here, you would actually end up writing probably a wrapper script that sits alongside these. So if we look at so these are the definitions that run the unit test reports, and there's a bunch of wrapper scripts and helper scripts alongside. These get checked out alongside your test definition. So in each of your test definitions, you can call directly to these scripts. And this is where you can write your own code that then calls out to particular support either in the test image or something that it can do over a over a connection that's made available so that you can then talk to external hardware according to however you can do it inside shells, scripts and things like that. Now, that's the simplest level of working with inside the test shell definition. If there's any way you can actually get that to work with the monitoring you want to do, then that's the best way to start. Inside the new dispatcher, there is support for what we're calling protocols. The first one of these at the moment is multi-node. The second one, which we're thinking of bringing in, which will be the VLAN-D, so that's building up dynamic VLANs inside the lab so that you can do proper network testing. These need obviously code changes inside the dispatchers to support, but they're basically a way of having calls to a known protocol at stages outside of the test shell if you actually have to do that. So for multi-node, we do that to make sure that the job is ready to start and to allow synchronization to happen at each of the levels. So this is an entirely custom protocol that multi-node is actually deploying here. It may change in time, but that's the status of it at the moment. And this kind of method, again, it has an accepts. And all the rest of it is entirely down to how this lump needs to work with the other actions. And that can be defined in the job submission that you use in this protocol, and these are the parameters for that protocol. So if we look here at yeah. So that is an example of how we would actually do that in the new dispatchers to specify the details to the protocol. And you would have another protocol under there for VLAN-D or whatever else actually goes on under that level. You can also run the unit test directly from where we go. There we go. It's from the command line inside the code, which is the simplest way of making sure you're aware of where you are and what you can actually do and what you can support and what's broken. That comes up if you manage to break your devel database, the one that's particular to your unit testing support. So we're adding a new migration or other changes like that, you can end up with a broken database, and then it will prompt you to say, do you want to blow it away? And go, yes. The other element of this is, if you go back to my local instance, so this is a section which is currently in review to go into master based on the new results app. So that is an extension, dashboard app, a scheduler app. They are extensions to Lava Server. They work as a not really self-contained, but it's a mini Django app inside. So you need to set it up in much the same sort of way. You don't have you share settings, but you do need to make sure that you have a urls.py with at least a beginning of the setup of that. You need to have a views.py and a models.py with a migration in place before you can do any work with actually testing the Lava Server extension and getting it to show up in various other places. So that's a Django specific set of changes to go on there. Talking of settings, one final bit into the settings in Lava Server. Here we go. So there's your code for dashboard app, scheduler app. That's currently the main daemon. There's another daemon under Lava Scheduler app management, which is the dispatcher master. The templates live under there. If you need to do extra work inside templates, to call custom functions, and you put them under template tags there. And then under Lava Server, it's principally about our settings. So yeah, you've got common settings. We generally don't mess with the middleware or add new middleware, or we don't import other people's changes on that level. So you don't need to worry about that often. That's how the development database is managed. The settings just set up something as a temporary throwaway. And that's the settings object. So that's the way you'll pull out new settings if you actually need to go that far, or to read existing settings. And one final thing which I do need to look at is the documentation takes you through how to create a super user, and the Django admin interface. This section, authentication authorization, is default to Django. All the rest of it is our own, apart from sites down there. So there's a lot of stuff under here to actually work out. If you're adding new sections, they'll show up in admin.py is where you can extend and make changes to the admin interface. That's where you get to do things like specify filters like this, so you can exclude retired devices and only look at certain things. So that's where you make things a lot easier for yourself as an admin and for other admins, is to be able to go through and just pick out particular filters, and that's all set up in admin.py. That's some nice documentation in Django. You'll spend a fair bit of time looking through that, and how to build a new admin layout on that. We've recently done a fair bit of work on that, and there's a little bit more to do in certain areas. But if you're adding new lumps to the database, new models, new things like that, then you're going to have to spend a little bit of time at least writing an admin interface so that it looks clean and is easy to work with. Some of those are very simple. And then some of the other ones are a little bit more complex. Spend most of your time as an admin looking at this level of what's going on with the devices. Right. Hopefully that hasn't gone over too many heads. But it's given an overview of where things are and where to find the bits of information, and to find your way through certainly the initial parts of the code and follow it through from there.
No, I think that was great, Neil.
Okay.
Thanks, Neil.
Does anybody have any questions before we go off air? All right, if you have any questions for the team or for Neil, you can find us on IRC on Freenode at Lenaro-Lava. So
#Lenaro-Lava, yeah.
#Lenaro-Lava, and we'll talk to you guys later.